Okay, so two notes that I actually want to add, which is not about your notes today, but it is an overall what I am saying. Okay, please continue to be careful. If I have something that says 4x squared plus 11x in a fraction of the left-hand side multiplied by like 4x squared minus 7x over here, I'm still seeing people are crossing out the 4x squared, so they hear they match. Can you do that? No, why not? What's the big thing? They have to be a multiplication cross off, and what are they right now? Yeah, it's a sum. This is a quantity. Alright, so you're either able to cross off everything in that quantity, or nothing in that quantity, or the whole quantity. Those are your choices. Everything can get divided by 4 in that quantity, nothing can get divided by 4 in that quantity, or the whole quantity goes. Now, looking up here, you see I have x, 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 and x. You see how everything has an x? Could I be able to get rid of that one of those x's then? Yeah, you could. So this square would become a first. That x is gone. This square becomes a first, and this x is gone. So you can do that. Basically what happened was that was a GCF of x up front, and the x's crossed off. But they all had to have it. The second note that I want to put in here that we have been going over is that there was one of your homeworks where it said something like this. It wasn't exactly like this, but it said x minus 3 in the top. And it said, or 3 minus x in the top, and it said x minus 3 in the bottom. And they look super similar. And I got a lot of people to cross them off. Why not? Why not? Right down here, this one's really good. So it's negative 3 plus the x. You have a complete opposite. Now, the cool thing that you could do with this, though, is if they are complete opposites. If they are complete opposites, what's 5 divided by negative 5? Negative 1, that's right. So if these quantities are completely opposites, you can actually cross them off and make them a negative 1. So that's a kind of important note to make. They're completely opposite. You can do that. Now, other rationality about why you can do that is say I took a GCF from this guy of a negative 1, then it becomes a positive x and a minus 3. You see how they're similar though? And you can cross them off. That's like a negative 2. GCF. So two things to be watching for on your homework. All right. So then back to the warm-up. There's a couple of notes in here for ourselves. The first guy was 1 over 1. So we were able just to copy, dot, plot. Cross off things that matched, reduce it, and then write our. The second guy, we first had to get a common denominator. We first had to put together 1, so we made this 4 minus 11, 12 to be 4 and 1, 3 and 1, 12, which is 37 12. And the bottom we made is 21 fourths. And once we got there, then we could copy the top, dot, and plot over the bottom, and then we could reduce. So that's the overall concept of what we're doing today. Is one thing in the top, one thing in the bottom, copy dot plot. And the last thing I want to add before we're talking about this, I want you to put quotation marks around this complex fraction. There is actually a thing in math called complexity. And it is numbers. They call it complex fractions because you have a fraction within a fraction within a fraction. And it looks complex. But I want you to know that going future exam, there is actually a complexity that is not complex. It's not really neat in a fraction and a fraction. So just being complicated fractions. That would be a better word, but here's the way to do it. Complicated fractions, but they're not complex fractions. That's the next question. Diagonal. Yeah, you can have a together or diagonal. It's like look what we did right here. We talked about that right there. If it was negative one, would it be what? Alright, we'll put this into use. I'm going to very carefully. This is the one time I like you guys to be writing left to right. Because there's no complex. So on number one, and your book will make it very clear. They'll make like a really dark line, which one is in the top of the column. They'll make it very clear for you. Alright, but looking here. This is one in the top and one in the bottom. So we are already good to go. Right? So we're gonna copy the top. Okay, give me a little cross off. So 1 plus x will be gone. Okay, what else? Okay, so take away one of the x's from each, top and bottom. Alright, what else? Good. Now, since I have x already in the top, I need to put a 1 up there. No, but it doesn't hurt. Alright, so our final answer is going to be positive 1x all over 2. Now, coming back to here, you did have an x in the bottom right there. So what's an x not equal right there? 0. Same for this guy right here. So I don't have to write them twice. I just write x not equal 0. And then right here, you have an x in the bottom. 1 plus x, negative 1. There are no, well, we're not solving it. There are no complexes there. Number 2. So again, can you guys see the very clear line with what's in the top and what's in the bottom? And on the top, how many factors do we have? 2. We need to make up 1. We need a common denominator. So look at the guy on the left. Oh, I noticed this is a minus side as well. What should I do? Plus minus. So this brings up an important note I saw in the homework. Making sure we get what we have to do here. If it's multiple things in the top, this one is going to see this one people can use this. Is that enough? What else has to get done on this top? Plus. So both things have to be taken. We do a little note of reminder. Alright, so back to this guy. Talking only about the top numerator. What does the guy on the left need? X. What does the guy on the right need? So we simplify him. So we have x minus 5 all over 5x. Can I cross off the 5? No, why not? Why not? What if it said 10x minus 5? Can I cross off the 5? Cross off the 5 and 10. That's 5 to 5. 5. Alright, in the bottom, denominator. What's needed in the guy on the left? What's needed on the guy on the right? So simplifying 10, he becomes 7x squared plus 10 all over 10x squared. Now I have one fraction over one fraction. So what I'm going to do, copy the dot. Hey, things are cropped off. Okay, so you're saying take away one of the x's from the bottom, and one of the x's from the top, right? Anything else? Do that? No, what if it was 10x right there? Can I do that? Yeah. Anything else? Nope, here's our answer. Now I am going to do x squared minus 5x. And the bottom just has 7x squared plus 10. And this goes with her restrictions, so just watching that right here, I see an x in the bottom and an x squared in the bottom, so it's x not equal. And then right here, I do see an x right here. This does have to leave that can equal, but I have not taught you that part yet. So I'm going to let you leave that blank. It's good. Because it will be imaginary. So, and this, perfect. There's the catch. And now we can divide everything by 2, right? No, why not? Because of the 7. Very good. Alright, number 3. You see the big denominator? They look pretty similar. They're not the same. Not cross them off. Nor can I cross off 2x over y and 3 like that. They're quantities. So how many of you are going to go in and write over 1 and over 1 like this? I'm going to make this plus -3. Let's talk about the big numerator. The guy on the left, he needs a 1. Do I really need to show that? No, the guy on the right will need a y. And so he gets simplified down into 2x and 3y all over y all over. Guy on the bottom, again, the guy on the left will need a 1. Do I need to show that? No. What is down the right? So he becomes 2x plus 3y all over y. Down to one fraction and one fraction, top to the top. Top to bottom. These things that comes off. Right? Why? Why okay. Okay, what else? Nothing else? Because it's 2x and 2x. No. What's that song? It's a quantity. So can I take a 2x without taking out a here as well? No. Okay, so I think this is it actually. 2x minus 3y over 2x plus 3y. So now let's take a look at, we have a y in the bottom, y in the bottom. Here's still a y in the bottom, so what can y not equal? And then right here, you guys want to solve for x or for y? Doesn't matter which one. X, Okay? So 2x plus 3y cannot equal 0. 2x cannot equal negative 3y. X cannot equal negative 3 over 2y. Or negative 3y over 2. Good. Those are your restrictions. Very good. All right, number 4. Again, these look exactly the same. They're not. So you need to be careful here. So in the numerator, what's this guy on the left mean? And this guy on the right mean? Same as down here. So we are now left with 9 plus r squared all over 3r all over 9 minus r squared all over 3r. Has 1 and 1. Can you do? Copy that off. Oh, you see it? Factors. What do you do? So this can be an answer, but if you want to take a look at factors, we can get our answer. 9 is what squared? So 3 minus r and 3 plus r. So that's important for us because now as we say the restrictions, we have r on the bottom, r shows up right there, what can r not equal? 0, and then right here, positive 3 and negative 3. And they're not exactly the same. Top is a plus though. They're not the same. So your answer is okay, that's good. Yay! Okay, what do you think the first thing I want to do on this one? Common denominator, so let's go on the left. Let's go on the right hand. Find the left hand. Let's go on the right hand. Not to be determined. Here we go. We're going to have this to be true. 6x minus 12 plus x squared minus 5x all over x minus 2 and x minus 5 all over. I think it's kind of fun when I use it. Look how big it is. All right, 3x minus 15. Careful here. Minus 2x and plus 12. Very good. All over x minus 5 and x minus 6. I'm going to combine my terms as I copied on the plot. I'm going to integrate here. So I get positive x squared, 6x, and negative 5x is 1x minus 12. I think that's a factor. Let me just say. No factor, yeah. Stop. Okay. 3x minus 2x is x plus 3. Okay, what cancels? This guy's factors into x plus 4 and x minus 3. What else cancels? Oh, this is a minus 3 in the bottom. Oh. Alright, so here's our final answer. X plus 4, x minus 6, all over x minus 2, and you have a bunch of restrictions. But it combines everything together and all of them are much. Right. I didn't look to your left. All right, have a great